Hey guys, this is my project, the animation of the Biped system, and the way it works is by setting multiple variables that contain the characteristics of the Biped system. These variables can be seen right here, and this is the first section of the algorithm. The second section is Dropit, and what this section does, it basically puts all of the pieces together and constructs the Biped system. The third section and last section is the simulation. In this section, the algorithm animates the biped system, and the animation is the biped system walking. So now we're going to run this algorithm. So first we upload the variables. We then construct the biped system. Alright, so we are in the second section and we can see right here that this is the biped system right here. So let's put this on the side and we'll head to the third section. Okay, so for the third section we're going to animate the biped system, and here we go. As you can see, the biped system is now moving, so that's its second step. And now I will explain each section with a little bit more detail. So let's head right into the next section. The first section is database, and what it does is it initializes all variables needed to construct the biped system. The variable body parts describe the body parts that make up the biped system. The variable coordinates say where the body parts are located. The radiuses determine the radius of the body parts, while transparency and colors are self-explanatory. Now we will create dictionaries, or as MATLAB calls them, containers. And we set the body parts as the key, but every other variable, which means the coordinates, radius, transparency, and colors, are values. I use dictionaries because the keys can call any value related to that key, which makes extracting information easy. Lastly, it is worth noting that the first coordinate belongs to the head, the second coordinate belongs to the neck, the third coordinate right here belongs to the torso, and the same thing applies for every remaining value and every remaining variable. Now let's move on to the next section. The second section is Dropit, and its main function is to construct the biped system. However, I will not explain every line in detail because the video would be too long. Instead, I will explain the core concepts of this section. As you can see, there is a for loop located right here, and its main function is to browse through all keys in the variable body parts. We do this because the body parts are the condition for the switch function. The switch function is located right here, and these are its conditions. Now, the switch function draws a sphere if the condition is the head and stores it in this variable. Similarly, it draws a rectangle and stores it in this variable if the condition is the torso. For the remaining body parts, the algorithm draws cylinders and stores them in its respective variables. It knows where to store the cylinder based on the body part. So if the body part is the neck, it stores it right here. If the body part is the right arm, it stores it right here. Or if it's the left arm, it stores it in the left arm variable. The same process applies for the remaining body parts. And this is very important because we will use these variables that contain the geometric figures to create the animation. Lastly, we run this section to construct the body parts, but before that, the variables in the workspace, so if you follow the mouse, these variables right here below the workspace, came from running the previous section, which is section 1. So if you run section 1, you should obtain all of these variables. By using these variables, we can now run the second section, Dropit, and we should obtain the Biped system. Now let's see. And here we go. We obtained the Biped system. Now let's move on to the next section, the simulation. In the simulation, we do many things, but the most important things are the k variable, the origin of the body parts, and the translation. The variable k will ensure every body part begins at the same point. The origin forces the body parts to rotate with respect to a point, which avoids deforming the biped system. And lastly, the translation moves the body parts through space. The k variable is located right here, and it goes through two updates. These updates change the value of k, so when the translation begins, all of the body parts are located in the same place. This means k directly influences the translation. The two updates can be found right here, so this is the first update, and the second update is right here. As you can see, each update adds 3 to k. This is because we want k to be a multiple of 3. So now we can go back to the beginning and right here. So now the algorithm calculates the origin for some body parts, which is shown right here. Then the algorithm uses the origin to produce the rotations. However, the rotations do not always use the origins calculated above. As you can see, only a few of the rotation functions use the origin. This is because the coordinates can be used as the origin, so there is no need to calculate the origin for every body part. And again, we use the origins because we want to avoid deforming the biped system. Next, we need to translate the body parts, and that is accomplished by the following lines. So it would be these lines right here. So this set up the translation, but the translation is placed inside this for loop. So by placing the translation inside this for loop, it makes the body parts rotate as they move. These are the core ideas of the simulation section, and by running the algorithm, we obtain the animation. So now let's run this section. Let's put this here, just expand this, and as you can see, the biped system is moving again, and it will keep moving until it exits out of the frame. And this concludes the video. I'm sorry I could not explain everything, but there isn't enough time. Anyways, thank you so much for watching, and goodbye.